We're rolling.
Okay, we're rolling. This is lesson 10-5 and 10-6. We'll start right here with 10-5. Point of tangency. The point of tangency is that one point where a line hits the edge of a circle. If a line hits the edge of a circle in just one point, that would be the point of tangency. If you draw a radius to the point of tangency, this lesson today says that will automatically be a right angle. And vice versa. If a radius hits the point of tangency at a right angle, then, if a line hits a tangent at a right angle, then it's coming from the radius. It goes through the radius. So, if it comes from the radius to the point of tangency, it will be a right angle. If it's a right angle, it goes through the middle. If it doesn't hit at a right angle, if you have a line from the radius and it is at a angle that's not a right angle, that means this is not a point of tangency. Maybe the real point of tangency is over here. Or maybe the line goes a little bit inside the circle. But if it hits the point of tangency from the center, it's got to be a right angle. Second part of 10-5 is about tangents from a point outside the circle here. If you have two segments that nick the outside of the circle, then from the points of tangency to this common point out here has to be a match. Those will always be equal automatically. If they come from the same point and they're tangent to the same circle, they're equal. That's such a small lesson, I figured we could do two. Lesson 10-6. If two segments intersect inside of a circle, we talked about if the angle is at the center, and we talked about if the angle is at the edge, but we haven't talked about if the angle is just like somewhere in there. Today we learned that that kind of an angle is half the sum. That would be half the sum of what it catches ahead and back. So if you're wondering about this angle 1 here, if it catches 90 degrees here and 40 degrees here, you would just have to add that up. 90 plus 40, 130, that'd be a 65 degree angle then. Half the sum of what it catches ahead and back. And of course, that's the same angle. If one of them's 65, so is the other. They're vertical angles. Also 10-6. What if you have an angle made by a tangent and a chord? Well, we kind of covered that already. We covered inscribed angles. They have their vertex on the edge. This one also has its vertex on the edge. And the rule is the same. They're just half of what they catch. If this angle catches 100 degrees of arc, then that angle is 50 degrees. Please understand, if there's 100 degrees of arc, there's 260 left, and that'll make that angle half of 260 or 130. Hey, that works out. They have to add up to 180. It'll work out. There's one kind we haven't spoken of. What about, we talked about the vertex being at the middle for a central angle. They are equal to what they catch. We talked about the vertex being on the rim when those are half of what they catch. And then somewhere in the middle, they're half the sum of what they catch ahead and back. But we haven't mentioned, what about if the vertex is outside the circle? new rule, half the diff. Those kinds are half the difference between what they catch near and far. The close one will always be smaller, and the far one will always be bigger. So if this one catches 30 degrees of arc here and 100 degrees of arc there, the angle will be half the difference between that, 35. That same rule applies whether they're two secants, two tangents, or one of each. It's the same rule. If the vertex is outside, it's half the difference between the far one and the near one. Now grab your sheets. We're going to do 6 samples right off your assignment. Why don't you swing over? Start with sheet 34, number 2. We need a suggestion from the audience of how we could figure out what this X is right here in sheet 34, number 2. Nathan has a thought.
Pythagorean theorem. I can't say that.
Yes, he's right. You could use the Pythagorean theorem, but wait, Nathan. Isn't that just for right triangles? There's no little right triangle thingy on there. He's backing down?
You had to go with me.
Is he backing down?
Stay with it, Ray.
Sure.
Go, Ray.
No.
He's not backing down. Good. It's a good thing he didn't back down, because we just learned today if that's a tangent and that's a radius, this does has to be a right angle. Nathan's ahead of his time. So just use the Pythagorean. 15 squared plus 20 squared, take square root. I think you probably get like 25. Let's look at this one right here now. What's the question, Kate? This is 36, number 2. This is the picture for it, and what did they ask?
They asked whether each segment is tangent to the given circle.
How could we decide if this segment is tangent or not? Need a hint? All right, Mitch, here's your hint.
You can take it and see if the Pythagorean theorem equals each other.
That's a good answer by Mitch Van Kalsvik. He says, use the Pythagorean theorem and test it. 4 squared plus 12 squared, does it equal 13 squared? If it does, he says it does not. So he recommends putting down that that is not a tangent. In other words, this line right here probably hits the circle a little more than in one point. Or maybe it's coming from the other angle, and if extended, it would hit it in more than one point. But it's not just a tangent. 36, number 7. This is a triangle drawn around a circle. We could say the circle is inscribed in the triangle. Do any of our ladies today have an idea of how we could figure out the perimeter of this triangle? They gave some of the pieces. No. just have to remember the second part of our lesson today. These are equal. And these, since they come from the same point, are equal. And these are equal. So you can find the perimeter of that triangle just by going 4 plus 4 plus 9 plus 9 plus 13 plus 13. It's not so hard. All right. I'm getting ready to bring in Kate here. You ready? All right, we're going to flip over to 43, number 5. Kate, I believe I explained this kind here today. How would one figure out that, which angle did they ask for? This one right here?
You would take 130 plus 90
That's 220.
and then divide it by half.
Okay, 220. 110.
And then that angle would equal 110.
110 right there. Is that the one they asked for?
No, on the other side.
Oh, what are we going to do then? Well, how are we going to get that?
Isn't it the same?
This one they asked for? Is there a problem? Well, can you see, Kelly, did she find the one they're asking for?
No, but I think the one she's asking
It's, okay, it's 70 because.
Ooh, ooh.
Of course, yes. Because it has to equal 180.
Ah, so she's saying right here that these two comprise a straight line, so they'll have to add up to 180, so that's 70. She's right. That's good thinking. Answer is 70 there. Nice work. Nice work. Elijah, you ready?
I'm good to go.
All right, Elijah, this one down here, we have to figure out X, and it looks like we kind of have, looks like it's kind of backwards. We already know this angle, and we learned that that angle is half the difference. Is there any way to figure out this X? Tell me if you need a hint.
Would it be like 30?
Yeah, but can you tell us how you get 30? We'd like to know how you get the 30.
Because 70 minus 30 is 40, and 40 divided by 2 is 20.
How'd you get the 30?
Put it together in my head.
Yeah, just kind of try stuff.
Yeah.
All right, that's pretty good. Another way to look at this 20 is half the difference. Well, that means the whole difference is 40. So the difference between 70 and this X has to be 40, so just do 70 minus 40. But he's right, it's 30. You might have to move over there for this next one. And we're going to bring in Jacob. Jacob, this one's probably the hardest kind we're going to be doing today. We're going to do a outside angle, both tangents. They didn't give us either arc. But we do have one thing going for us. We know they have to add up to 360. So can you suggest an expression I might write on this one right here? This is X. What could I write for an expression right there?
Would it be 61, 60, or 360? Define the percentage, and then find.
Oh, I see what you're thinking. We could just write that this would be 360 minus X degrees.
Good.
Okay, we still don't know either one. But we know according to that plan over there that the big one minus the little one must equal 68, right? They tell me you passed algebra last year, son. What can we do here?
I'm thinking you can add or get negative 2x out of two x's,
Nice.
and maybe add them to the other side, and then take 68 minus 360. So you can get positive 3. Or you can take 360 minus 68, either one.
Oh, like that?
Yeah, either one works.
Make this negative 292. Am I doing that right?
Yep. Then I'll check. 146. Yep, 146.
Nice help there, son. Nice algebra. Good job. We're gonna wrap the lesson up there, and you guys have an assignment for the Tuesday we come back. Sheets 34, 36, 43, 44, 45, 5 sheets. Over and out. She's gonna get a focus on it.